In this lesson, we are going to consider the study of what circular motion. But in this video, we are looking at the motion of a car on a banked road. Okay, so this is what we are looking at. So with this system here, this is a car moving in a circular path, okay, on a banked road. Okay, so you see the angle of inclination here, which is what, theta. Okay, you have the angle of inclination there. Then you have the radius of the curve to be what, r. Okay, then you have the forces acting on the car, which is the normal force and then the weight force. We are considering this system to be a frictionless system, so which means that there's no frictional force between the car tires and then the road. So let's take note of this. So looking at this angle theta here, okay, this angle theta here will be the same as what, the theta that the normal force makes with the vertical. So let's take note of that. So if the angle here is 20 degrees, this angle here also what, 20 degrees. Okay, so let's take note of that. I'll talk about how the angle was what's in there at the end of this video. So let's continue. So due to the normal force being placed at an angle, it is going to have x and y component. Okay, it's going to have what, x and y component, and this n sin theta here will be the x component of the normal force, and then the n cos theta here will be the y component of what, of the normal force. So let's take note of this. In this case, there's no friction here. Okay, there's no friction here, so the force that is holding the car in the circular path will be the horizontal component of what, the normal force. Okay, so the horizontal component of the normal force will be the centripetal force in this case. So that will be the force that will hold the car in place to prevent it from what, skidding. So now let's perform the analysis on this system. So you are going to consider the forces acting on the car in the vertical and then horizontal direction. So looking at the forces acting on the car in the horizontal direction, okay, so looking at the forces acting on the car in the horizontal direction, from Newton's second law, you know that the net force acting on a body in motion equals what, the mass and then the acceleration of that body. So the sum of all the forces in the x direction should be equal to what, the mass of the body times what, its acceleration. Okay, should be equal to what, the mass times what, its acceleration, and this acceleration will be centripetal acceleration. Okay, so let's continue. So we are considering the forces in the x direction. Okay, in this case it is only the x component of the normal force. Okay, so that will be n sin theta because mass times what, centripetal acceleration, which is what, v squared over r. Okay, so this will be our equation 1. So now let's consider the forces acting on the car in the vertical direction. So we are going to have n cos theta, okay, minus the weight. Okay, minus the weight, so that will be minus mass times acceleration due to gravity, and this should be equal to what, mass times the acceleration of the body in the y direction. But this car here is moving in a horizontal circular path, so there will be no acceleration vertically, so that was 0. So we are going to have n cosine of theta to be equal to mass times acceleration due to what, gravity. So this will be our equation 2. Okay, so this is what we have now. Okay, so now we want to find the maximum velocity v, okay, which the car must move to prevent it from skidding off this circular path. So let's look at how you are going to do this. So looking at this normal force here, okay, so I have the normal force here. This is the normal force. Okay, this is the x component, then this is the y component. Okay, so we have the angle theta here. Okay, so let's say I draw the x component here. This is what, nx, right? So when I take the tan of this angle here, tan theta will be equal to what, opposite, right, which is what, nx over what? Adjacent, which is what? Ny, right? So the tan of the angle theta will be equal to what? Nx over what? Ny, right? And then we know that what? Ns equals what? Ns equals what? N sine theta. That's what we have here. And then Ny equals what? N cosine of what? Theta. So when I do this will give me tan theta to be equal to what? To be equal to nxy, which is what? N sine what? Theta divided by what? Ny, which is what? N cosine of what? Theta, right? But let's come back to what we have here. Okay, let's come back to what we have here, and then let's look at what we have here and then what we have here. Okay, which is the equation 1 and then the equation 2. Okay, so from the equation 1, we know that what? N sine theta equals what? Mv squared over r, right? So you can do that substitution here. Okay, so let's continue. So let me write this here. You have tan theta equals n sine theta over n cosine of what? Theta. Okay, so now I can clean what you have down there for more space. Okay, so now, so from equation 1, we know that what? N sine theta equals what? Mv squared over r. So we are going to have tan theta to be equal to what? Mv squared over r, right? Divided by what? N cos theta. And then we know that to be equal to mg. Okay, so divided by what? Mg, right? So rewriting this, I have tan theta to be equal to mv squared over r, right, times what? 1 over what? Mg. So this m will cancel out this m. Okay, so let's continue. So let me fill out space here. Okay, so let's continue. So now we are going to have tan theta to be equal to v squared over what? Rg. Okay, and now you want to find the velocity, which is what? The maximum speed that the car must move to prevent it from what? Skidding. So all you have to do is to find a way to make v the subject. Okay, so let's go ahead and do that. I'm sure by now you are done with it. Okay, let me free up some space that I also do mine. Okay, so making v the subject, we are going to have radius times acceleration due to gravity multiplying tan theta. This should be equal to what? V squared. So you can take square root of both sides, and I'm going to have v to be equal to the square root of what? R times what? Acceleration due to gravity tan of what? Theta. Okay, so this is what we have now. So let's say in a situation whereby you are given the radius to be equal to 120 and then theta to be equal to 18 degrees. Then you just have to substitute them into this formula that we have here. Okay, so let's do that. Okay, so we're going to have v to be equal to the square root of what? The radius, which is what? 120 times acceleration due to gravity, which is what? 9.81 times the tan of the angle given, which is what? 18 degrees. Okay, so now let's look at this. So that is square root of what? 120 times 9.81 times tan of what? 18. Okay, so doing that, that'll give me the velocity to be equal to 19.56 meters per second. So this will be the maximum speed that the car must move, okay, in order to prevent it from skidding off the circular path. So that's all for this video. So let's take note of this formula that we got here. Thank you very much for watching this video.